In 1971, they dropped a hammer and a feather on the moon at the same time, and this is what they found.
And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
They both landed at the same time, but how? Common sense tells us that heavier objects fall faster because we see that all the time on Earth. One of the most common equations in physics is force is equal to mass times the acceleration, which, if you rearrange, gives us force divided by mass is equal to acceleration. But what is the force that acts on the object? It's gravity, or the mass under the influence of gravity, which in other words is known as weight. The equation for weight is equal to mass times by gravity. So now we know that force is equal to weight. Then we can substitute that into the equation, and that will give us mass times our gravity divided by mass is equal to acceleration. And therefore, if the mass of a hammer is 1 kilogram and you put it in the equation, then 1 times by 1.622 divided by 1 gives us 1.622, which is a gravitational pull on the moon. The masses cancel each other out, and therefore any object with any mass will have the same acceleration. And it's like that on Earth as well. The only thing that changes is the gravity. On Earth the gravity is 9.8, so that's why if you drop a hammer, then it would be 1 times by 9.8 divided by 1, which is equal to 9.8. And same with all the other objects like a bowling ball, a feather, or anything else. The answer will always be 9.8. But then why do things on Earth fall slower than others? Like, why does a feather fall significantly slower than a hammer? This is because of air resistance. That's why when the BBC did the same experiment on Earth in a vacuum with a bowling ball and a feather, they both landed at the same time.